Hello everybody! I'm happy to see you again for this last lecture about gaseous fuels. As explained by Maria during the first week, one of the key drivers for the transport sector is the reduction of CO2 emissions. CO2 emissions can be decreased thanks to adapted human behavior, such as car sharing or intelligent driving. That will be presented this week by my colleague Cindy. A better efficiency of the engine also allows CO2 emissions to be decreased. Remember Maria's lecture of the third week on this subject. As we have seen together this week, renewable fuels such as biofuels are also a good solution to decrease CO2 emissions. And the last way to reduce CO2 emissions is the use of low carbon content fuels with fossil origin. These alternative fuels are, for example, compressed natural gas, CNG, liquefied petroleum gas, LPG, or hydrogen, H2. This is what we will be looking at in this lesson. Compressed natural gas, CNG, is mainly composed of methane, CH4, LPG, liquefied petroleum gas, also called autogas, is mainly composed of propane, C3H8, and butane, C4H10. CNG and the LPG are used in spark ignition engines. One of the main interests of these gaseous fuels is their quite good well-to-wheel balance. This figure from the Joint Research Center presents the well-to-wheel balance for many types of fuels. The greenhouse gas emissions balance is on the y-axis, and the x-axis represents the energy balance. Look at the points which represent gasoline and diesel fuels. Today, well-to-wheel greenhouse gas emissions for CNG lie between gasoline and diesel. Beyond 2020, greater engine efficiency gains are predicted for CNG vehicles, and well-to-wheel greenhouse gas emissions will be close to those of diesel. The origin of the natural gas and the supply pathway are critical for the well-to-tank greenhouse gas balance. LPG provides a small well-to-wheel greenhouse gas emissions saving compared to gasoline and diesel. The decrease of CO2 emissions for these gaseous fuels is due to their higher hydrogen-carbon ratio, as shown in this table. These gaseous fuels also display a high knock resistance, as shown by the high octane number. Lastly, relevant properties of these fuels are related to the fact that they are gaseous. Their storage limits the autonomy of the vehicle. Remember this figure presented during the first week by Nadine. Liquid hydrocarbon fuels remain the most efficient in terms of energy content, far in front of gaseous fuels. So CNG and LPG are interesting products as they lead to low emission levels, especially for CO2. The resource, natural gas, is widely available. And interesting taxation is proposed in some countries. For example, in Europe, the price of LPG is 40 to 50% lower than the price of gasoline. Still in Europe, with CNG, you can drive twice as many kilometers for the same price compared to gasoline. Nevertheless, the use of such gaseous fuels requires adapted engine calibration, and the storage and distribution network remain the main challenges for the development of these fuels. Today, LPG is not used very much for transportation. It is dedicated to domestic usage and chemistry. Concerning CNG, the natural gas vehicle sales are directly linked to the number of refueling stations and the fuel price. This map shows the number of natural gas vehicles worldwide. In 2013, there were 17.7 million natural gas vehicles worldwide, including 16.3 million passenger cars. The development of natural gas vehicles is really relevant, as in 2004 only 4 million vehicles were available. Now let's switch to another gaseous fuel, which is hydrogen. Hydrogen is used for fuel cell vehicles. Hydrogen is converted into electricity for the motor using a fuel cell. A fuel cell is a device that converts the chemical energy from a fuel, hydrogen in this case, into electricity through a chemical reaction with oxygen. There are many types of fuel cells, but that all consist of an anode, a cathode, and an electrolyte that allows charge to move between the two sides of the fuel cell. Electrons are drawn from the anode to the cathode through an external circuit, producing direct current electricity. The only emission is water. As the main difference among fuel cell types is the electrolyte, fuel cells are classified by the type of electrolyte they use. The fuel cell used mainly in the transport applications is the proton exchange membrane fuel cell. Hydrogen can be produced from several resources, such as natural gas, mainly methane, CH4, coal or biomass, for example wood. In order to produce hydrogen, two main routes exist. The first one is thermal production. It consists of a chemical transformation process. It generally involves a decarbonization of a hydrocarbon or organic feedstock and the splitting of water. The second route is electrolysis, which uses electricity to split the water molecule. The most widespread process to produce hydrogen is steam reforming of natural gas. The catalyzed combination of methane and water at high temperatures produces a mixture of carbon monoxide and hydrogen. This mixture is known as syngas. Many potential hydrogen production routes exist. The well-to-tank balance for greenhouse gas emissions is critically dependent on the pathway. Indeed, hydrogen produced from wood has a very low well-to-tank balance compared to hydrogen coming from natural gas, and the worst case is hydrogen coming from coal without CO2 storage. Despite technical advantages such as no exhaust emissions and interesting energy conversion efficiency, fuel cell electric vehicles remain prototypes and demonstration cars. The present cost of fuel cell vehicles greatly exceeds that of conventional vehicles, in large part due to the expense of producing fuel cells. As for the other gaseous fuels, storage and the refueling network are the key points for future development of this pathway. Hydrogen is a highly explosive gas that will have to be treated with care when using it to fill your vehicle. It requires high tankage weights and high storage vessel pressures. Large investment in infrastructure would be required to fuel vehicles. The tank-to-wheel balance of hydrogen is very interesting, but concerning the well-to-tank balance, that means the production of hydrogen, the greenhouse gas emissions level strongly depends on the hydrogen production route. Thanks to this lesson, you have now a basic knowledge about gaseous fuels, which can be an alternative to the usual liquid fuels. Now, I invite you to follow the last lesson of our MOOC with my colleague Sydney. I hope you have enjoyed these lectures. It has been fun talking to you. Bye!